So yeah, let's start. Okay. So hi everyone, and welcome to the World Space Week event. Okay. So we are in the fourth session. Okay. So this is the third session, I guess, na? This is third session or fourth session, guys? The audience is from the day one. Just tell me, this is the third session or fourth session? Third session. Okay. So are you guys excited for the today's session?
Super excited.
Super excited. Okay, guys. First for me. Okay. Okay. So yeah, today we have our friend Sibsankar Palit, who is the founder and the team leader of Life 2 and Beyond. Okay, and Life 2 and Beyond is doing really good work. Okay, so they are on a mission on doing ethical R&D. Okay, and outreaching. Okay, they have a program Outreach Sarabai. Okay, so they are promoting the space education to all the students. Okay, all the communities. Okay, they are really active in the field of astrobiology, and they have a really set of good team players. Okay, so like I know some of the team members. Okay, like Shubhajit is there. Okay, Barua. Okay, so these are really good players. Okay, so today we have one of them, Shiv Shankar Palit. Okay, so he will be sharing his experience. Okay, and he has been recently I been working with the Blue Marble Space. Okay, as a visiting research scholar. So yeah, he holds a really good experience in the field of astrobiology. Okay, so further, let me give the stage to the Shivshankar Palit. Okay, they will be giving you and taking you on the journey of astrobiology and giving you the answer that is there life beyond our universe or not. Okay, so yeah, over to you, Palit.
Thank you very much, Arjit, for a great introduction. I will obviously come to this very part whether there is life outside Earth or not. There's a very and also there are some myths related to it. I can just give one hint, a kind of spoiler at the very beginning of the show. I call it a show lecture because I'm not here to deliver a lecture, but rather to share about my love for astrobiology and also about life in the universe and also opportunities. At the end, I will also share about some bonus opportunities that I have to share for you all. I hope that majority of the people are from India as well as and looking for different opportunities in the space sector. And also, without further ado, I will begin today's session. Thank you again. So, as we all know, that the World Space Week this year has the very theme of space and entrepreneurship. And my topic here today is astrobiology, making space education more accessible to all. I will come to the entrepreneurship part at the end. So, Apaz Arjit has already mentioned that I am the founder and team executive officer of Life 2 and Beyond. Apart from that, I have recently taken up some new positions as the coordinator of Space Crew Working Group of Innova Space UK. And also, after finishing the Young Scientist program from Blue Marble Space Institute of Science, I've also taken up the additional position of visiting scholar out there on live detection knowledge base, an initiative by NASA's Center for Live Detection. I'll discuss more at the end about that. So coming to the topic itself, before beginning any topic, means in some of the outreaches I have been a part of, I try to first give an overview about space in general and its breadth. Finding your place in space. So, according to me, means if anyone wants to join space, there's a simple formula. Just add these three words, any of these three words, space or astro or cosmo, to any existing field, and you get a new field. Like space is not a new field, frankly. It's an extrapolation of all the existing fields that we already have, be it engineering or medicine or other sciences or even arts and commerce as well. So just add the pinch of salt, optimum amount of salt to the food, whatever subject you're studying, and you get a good taste of whatever subject you're studying by getting a new subject. For example, I'm studying chemistry. If I add space or astro or cosmo, astrochemistry, cosmochemistry, space chemistry, it becomes a new subject to be explored in different sense in a different setting. So that's what space is all about. Okay, and anybody and everybody can be a part of space sector. And here you behold, my dear friends, the range or the spectra of careers in space, from the very sciences to the very arts and journalism and entrepreneurship, sustainability, commerce, everything. You have a whole lot of menu in space to just choose from. Okay, and anybody can be a part of it. And that's why it's said space is vast and unexplored. Find your place in space. Okay, and today I'll be discussing about astrobiology or cosmobiology. Remember that cosmobiology or astrobiology is a bit different from space biology, because astrobiology relates to a different approach of studying life, and space biology is about applications for future space exploration, means in the human context, not about the origin of life or other things. So there's a bit difference about that. But then there's also common meeting point out there, in the sense that about the future of life, both astrobiology and space biology are concerned. Okay, next we move on to the quote. Just remember this quote. You don't have to remember anything from this talk or this things that I'm sharing. Just remember this quote, and you will find the essence of what astrobiology or space is all about. The cosmos is within us. We are made up of star stuff. We are a way for the cosmos to know itself. As said by Carl Sagan, a very famous astronomer, astrobiologist of his time, and a great science communicator. First, I would, as I said, I'm not here to deliver a lecture, so I would certainly encourage people to interact. Would you like to share something, anyone, like switching on your audio or like by writing in the chat what this quote means? Come on, let's be proactive enough in terms of interaction. Just whatever comes to your mind.
So may I say anything?
Yes. Rajiv, you can go.
Okay, so it's a famous quote by Carl Sagan, and it is showing that we are human, on the earth. We are made by stardust. Like a human life is not made on the earth. It is made by created by some space elements.
Okay.
So it is giving the signal, and it is also giving a message that if you want to explore the universe, first you need to explore the human body, so you can get some idea, like if you can see the iris of human eyes. It is just like the image of universe, and the brain
Ah,
mapping. If you see the image of brain, that also gives some signal of a universal structure.
mm-hmm.
So just like that, so some indications about
Yeah, the first, like, see, the answer that you have given is very extremely great. Like the first part, that the elements are made in stars and all, and also the second part that you said, that is more of a biased kind of, or what we humans give meaning to the universe. Like for example, the similarity that we try to find, or the meaning that we find in things, like the similarity, as you mentioned, the iris of our eye, or the any nebula, or like the networks and all. Like there's similarity, I agree, but that is what we perceive. But that is extremely great answer from you. Anyone? I would like to take one more perspective. Keshav,
Sir,
you
may I
take.
say? Sir, may I say?
You don't need to call me sir. You can call me Palit by name. No issues. You say.
Okay, so by this quote of famous astronomer Carl Sagan, who is himself very famous about his space explorations, and also for the Voyager 1 project, he said this line, and I think it's very applicable for us and the study of universe, because it means a lot. At first, it says the cosmos is within us. This means a great things. Means the whole cosmos is actually inside a human body, because the things we have in our body is much vast. And if we can explore that much, it will be very easy for us to explore the rest of the universe, because it's also so vast that it needs get patience, and exploring it is really fascinating for the
Right,
human.
right.
And next it comes, we are made up of star stuff. It is also very true, because we are all made up of molecules, atoms, and we are all the products of the stardust that are created millions and billions of years ago.
Mm-hmm.
It's just within us, and we can study them within us very carefully and
Mm-hmm.
productively. And next, we are a way for the cosmos to know itself. Means we are knowing ourselves as well as the cosmos, and as we will know the
How
cosmos,
are
we
we
will
knowing
know ourselves.
ourselves? How is
Yeah,
the
means
cosmos knowing ourselves through? How is the cosmos knowing itself through ourselves? Explain that part.
okay. I mean actually that
human mechanism or human working of brain or any other sectors is as complex as the working of the cosmos. So I think if we can explore ourselves in a better way, then we will also be able to explore the other rest of the universe in more effective and fascinating way. So that's what I think I made as I can
No, no,
understand.
absolutely. Thank you very much for your
Right.
perspective. Like the first part, everyone is getting right. The second part, everyone is trying to answer from their end. Just think it from a very simple manner. Aditya, you would like to answer something, especially with regard to the last line. We are a way for the cosmos to know itself. Simple. A is equals to B is equals to C, A is equals to C. Like that. Aditya,
Yes, sir.
you can call me Palit. Yes, you can go ahead.
Yes, sir. So, like, if we means read the line that we are a way for the cosmos to know itself, then like in the above line there is also said that we are made of stardust. Means the human beings are the made of stardust means like and whenever a star happens, at that time the particle gets ejected by the star. Means that is in our human beings body. So we are a way for the cosmos to know itself means if not like if a cosmos was a real being for if we see the perspective like if it was a real being then if it wants to know itself then it can see on us that how we were etc.
Right. Here you got the nerve.
So, sir,
Yes,
can I?
yes, yes, yes. Say.
So like in this quote, Carl Sagan explains that universe is everything in us. So example, in our atoms of nitrogen in our DNA and the calcium in our teeth,
Right, right,
like
right.
that,
I've
it
heard
is
that.
all forged
Hmm.
from the interiors of the stars. Like the
Hmm.
building blocks that make up our cells, also like it all comes from the dying of stars. So like
Right.
basically, universe is everything.
Huh.
Like that.
Then the last part.
The last part, we are a way for the cosmos to know itself. I think he's saying that uh, like we are the ones we will be knowing the cosmos. Like I didn't understand really the last time.
Okay. No issues. Thank you very much, everyone, for your perspectives. It's very simple. As I said, A is equals to B is equals to C, A is equals to C. If we are made up of the elements are made in the stars, core of the stars, and other cosmic processes. We are made up of that elements. Means A is equals to B, right? And we are made up of that elements means what? First, we became alive, and probably through evolution, we have gained greater consciousness and thinking capability enough to even explore space now. First, we were just one continental, like in Africa, and then we migrated to other continents, and today we are in different continents. Today, we aspire to become multiplanetary, right? And slowly we reach out back to the stars where we were made. So, in itself, the cosmos it's trying to know itself through us. Okay, it's a kind of circular process that goes on, and that's what astrobiology is. Okay, so I think there is some bit of philosophy here, some bit of science here, a bit of poetry out here. It's an excellent mixture of what Carl Sagan produced in his words, trying to explain the most profound in the simplest of words. Okay, and whole thing is going to be my presentation actually. Prospects in astrobiology. Again, I would like to request you all what comes to your mind when you hear the name astrobiology. I'll just request people to be a bit
So
fast
may I?
because we have.
Yes.
Okay, and also insist people not to call me sir or mister. You can directly address by my name. Okay, you
But
can go
I
ahead.
think I should call sir because I am a student of class 8.
I'm also a student. You can say I am born today only. You can continue. Okay.
Okay, okay, fine, fine. So if I hear the thing astrobiology, then at first the two things come in my mind that astro means something related to space or in universe, and the rest biology is the study of life. So I think the study of life beyond Earth or the study of life in our universe or varied life forms in our universe or something
Okay,
like
this basically,
related to
very
life.
sorry to cut short here because we have
Yeah.
very less time here.
Okay.
We have to take more perspective.
It's
Very
okay.
sorry.
It's okay.
Basically, what you mean
Yeah,
that
yeah,
life
yeah,
beyond
yeah.
our Earth, right?
Mhm.
Life in the universe, as you say. Okay, thank you. We have Keshav. Yes.
So astrobiology is basically like studying about the life forms beyond our Earth.
Okay, beyond our Earth. Okay, same point.
Beyond that, same
Uh,
point.
Vinod Kumar or Aditya, anyone can go ahead.
Ye- yes. So according to me, like astrobiology has two like phases. One phase is means finding life out of Earth or like extraterrestrial life, and second
What
is
kind of extraterrestrial you mean?
living. It means
Obviously, living means I mean like what
yeah.
kind? Because there are
Uh,
simpler, there is intelligent life as well.
yes, means any can be there, but simpler would be more like simpler is here because if we say about complex, then like we can also try with radio signals like earlier in
Techno
the session you
signatures,
had
right?
tried.
Right.
And the second phase of astrobiology is the study of life, means above Earth or in space. If, for example, in ISS,
No, no, that is space biology. That is not astrobiology.
means
Okay,
in
that's why I said
astrobiology, yeah,
that is what I was trying to put forward the difference. That means the study of this kind of effects on like living things beyond Earth and all that is actually space biology. Astrobiology has a different approach towards that. Okay.
okay, so thank you, sir.
Uh, Preet Varu, you can share.
Yes, sir. So, by astrobiology, I mean like study of life, which
Okay, tell
can
me
be present
something apart from life in the universe or beyond Earth. Tell me something extra.
like studying about the planets which have possibility of blooming of life, where we can, us as a future can see as a next Earth or where there can be life.
Okay. Thank you very much, everyone. Through this very question, I have tried in many sessions to understand the audience. Like, means I feel that this audience very well know, at least to some extent, about astrobiology. I'm very happy about that, and because many a times when I have asked people like where what comes to them, even to experts who are like PhD postdocs in biology, not in astrobiology and all, so they say like it's about aliens or like also this point comes out like life beyond Earth or life in the universe. Remember, life in the universe also includes you and me, so it's also about life on Earth as well. Okay, it's not just life beyond Earth. Okay, so it's everything about life. It's about understanding the very nature of life. Coming to the blah 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 as written on NASA's website, what astrobiology is. Astrobiology is a scientific study of the origin, evolution, distribution, and future of life in the cosmos. The origin, how life originated on our Earth, or even on other planets, if possible, evolved like from simpler to complex life forms like us. Then, as you were mentioning, the presence of life beyond Earth, whether means how life is distributed, if any, in any parts of the universe, including our solar system, and the future of life in the cosmos. That's where life can be or where life can start or the possibility of habitability. And here comes a connection with space biology, where astrobiology can be connected to space biology in terms of habitability on other planets. And that was what Aditya, I think so, was also mentioning. Okay, so here you can connect astrobiology with space biology. Now coming to some more things, interesting one. Remember, astrobiology is not about astrology because I have seen many YouTube videos of astrology that starts with the very celebrated quote of Carl Sagan himself that is very misinterpreted, that life can be connected to planets, how planets can affect our daily lifestyle. That is all bogus. There's nothing to do with our daily life. And also remember, astrobiology is not about aliens. It is more than that. If you have joined this session to know about aliens, I'm sorry, my dear friends, there is much more beauty to life itself than to just talk about conspiracy theories. Okay, and I'll share, but yes, alien is a part of thing and it's a curious thing. I'll discuss it as a very short part in this particular talk. According to you all, is astrobiology a new field? What do you say?
No, I think it was there.
Okay, just answer in yes and no. Okay,
Okay,
yes or
means
no.
no. No,
Okay,
it's not
others,
new.
others. Okay, no. Others. Any other pointers? Okay. Yes, you are right. Astrobiology is not a new subject in the sense that it has newly come up in India, obviously, but or in the US 50 years ago it started, when the start of NASA and all. But if you see logically, according to the definition, how life, it is very, very connected to the question, what is life? How did life come about? Who are we? Where did we come from? Right. These type of questions haven't you heard related to religion or like any kind of religious texts as well or ancient scripts as well? Like every religious text, be it in the Hindu culture or in the biblical, or be in the Islamic or any other religion, or even in the ancient scriptures, it is very well. As we hear about stories about evolution and even not about evolution, generally about how did life come about through creation and many more theories. But remember that those theories or those pointers are mostly perspectives. But then this curiosity among humans to think where we came from, what's the you can say initiation of life has been there from the very beginning of our civilization, and that's the very essence of astrobiology. But today, after many, many, many generations after human civilization, we have the scientific tools enough and also the prerequisite scientific facts to start exploring or even explore this from a scientific perspective in an evidence based manner to truly reach out to the truth of what took place or what can be these conditions for life to exist. Okay, coming to the story of our universe. Our universe began some 13.7 billion years ago, and we are here in a stage where we are living on Earth. And the very first line that comes in most of your science textbooks in school or even in your chemistry textbook, I can bet, is wrong. Everything is made up of atoms. Unfortunately, it isn't. Just 4 to 5% of the whole. Okay, somebody I see that has written astrobiology was known to our forefathers. Nothing was known to anyone. We are still in the way of knowing. Okay, they have known something, and based on their conceptions, we know, means we get to know even better. Because as Isaac Newton himself said, that if I have seen further, it's because I stand on the shoulders of giants. Our forefathers are our shoulders on which we stand today to see farther into the future and better and more evidence based. So the cosmos is made up of 5 to 4% of matter, as we see that you and me and this computer and everything is made up of, and rest is dark matter and dark energy. Apart from that, you can find that the elements, means if you see just the material composition of the universe, just 2% of what the universe, the matter is there in the universe, the 98% is just hydrogen and helium, and the rest is just the heavier elements. And what are the 6 most important elements? Anyone who knows for life? Out of all the 118 we know till date?
Carbon, nitrogen,
Right, right.
oxygen.
Carbon, nitrogen, oxygen.
Then would come.
Hydrogen.
Right, hydrogen, sulfur,
Yes,
and one more is there.
Phosphorus.
Right. Schnops elements, as we call it. CHNOPS. Schnops elements. These 6 elements are found in all 98% of life on Earth. Okay. And there are more 88 to 88 elements required for different life functions and all in different proportions in different life forms. And remember, the 10% of our what is that called, matter is in the interstellar medium, inter and between stellar system, that kind of place in space, and mostly near to the stars. That's quite, as it's quite obvious, because elements are made within the star's core or nearby regions. And it's quite, you can say, This cyclic process goes on where from molecular clouds to from diffuse molecular clouds like spread out dust clouds of matter to dense cloud where the gravity pulls in all into a more kind of, you can say, dense cloud, and then starts the formation of star and planets where eventually molecules are formed. So people who think that molecules are formed on Earth, they are wrong. Molecules are born in space. Chemistry is born in space. Okay. Even at times I have to explain to my professors as well. Chemistry is not about Earth. It is mostly about space. It has come from space. So that is the thing, that many things are there that we aren't taught in classroom, but they are most beautiful and the most fascinating things ever. And then you can say that the asteroids and all are made during the star and the planetary formation. Today also many chemistry, there are different kinds of chemistry that takes place in the harsh space environments, and the planets are themselves are formed after that. And as you know, after the full means the star means the nuclear fusion reactions and fission reactions gets done, so the energy is no more there. So based on its mass, either it implodes or explodes, and eventually distributes some matter into space, into different parts of space. It gets distributed, and this cyclic process goes on and on. Just remember the asteroids that I mentioned that are formed during the star and the planetary formations. That time only the main chemistry takes place, and perhaps one of those few of those asteroids may have delivered some life matter here on Earth as well. That's a probability. There is a theory after this, panspermia theory. I'll discuss that. Yeah, and this is the slide that summarizes the cosmos is within us. We are made up of star stuff. We are a way for the cosmos to know itself. Okay, so the thing that there is a means, quote in Hindi and Bengali. I will not say because I see many people are here from different backgrounds, but I'll just translate it in English. That the essence of the creator lies in its creation. Okay, so the universe is within us. The essence of the universe is within us. We are the universe, perhaps. Okay, and that's what Carl Sagan also tried to put in his most poetic words ever. And there's a very beautiful, you can say, mural or wall painting from the Center for Chemical Evolution at Georgia Tech in US. You can see very beautifully how chemistry is taking place in space, and like through volcanic activities and other like thunder activities and all, molecules getting more complex, and then eventually getting complex enough to form biomolecules, and eventually the diversity of life and many more. Okay, and NASA, as per a panel, tried to define life. It is very difficult to define life, but this is a common definition that is considered. Life is a set of self-sustaining chemical reactions capable of Darwinian evolution. Means first that there should be matter. Second, that should be self-sustaining. Means nobody is going to come and help you evolve or like means face challenges. Okay, and also you have to evolve over time as per conditions and survival of the fittest, obviously, adapt to changes. The one who doesn't adapt to changes and perhaps gets perished. And that is also same for entrepreneurship, on the very note of the theme, that you have to adapt yourself to the condition and to the market and keep on evolving. So life inspires entrepreneurs as well. And I'm talking about the biological life. Okay. But then again, there are other forms. It is very difficult to define life, because if you say life is something that grows, then can you say that fire is life because it also goes by like a combustion and all? No. Life is something that multiplies or reproduces. Can you say AI alive? Means that can kind of multiply itself in a system? Or can you call virus alive, that is outside a system not alive, and inside a system it's alive? We don't know. So till now there is no common definition of life. So that's why it's very difficult to define life as well, and that's why this particular subject is important. Coming to the concepts of habitability and durability. Habitability, most probably all of you know, you have heard about the habitable zone and all, but it is a very bizarre concept in today's date as well, because even life can be present in planets, means in a place which is not even within the habitable zone of a star system. Okay, if you want to know, I can describe more at the end in the Q&A session and all. But then there is a concept of durability, that like habitability is like the conditions present in a planet or in a place that can sustain life. Means if we as humans or any microbe is sent to a planet which has conditions means able enough to sustain us, then it's habitable. Okay, but durability is something different. It's a very new concept, came up last year only in one of the publications in Nature, that durability is about the conditions that allow the origin of life, like based like we study about exoplanets and different kinds of solar system celestial bodies. Studying their features or their spectroscopic data or other things, we can kind of predict whether life may have been there in the past or will originate in the near past. Near future. In the near future, if life will be able to originate there or not, based on the conditions. Both are quite, you can say, thrilling concepts to just know about. Coming to the origin of life theories, there are many, beginning with the creationism theory that's in the religious texts, various, but that has been debunked long ago. There came many theories. Okay, after that, but the two generally considered theories is the exogenous delivery, that is from outside delivery of life material of simpler form of life through the asteroids or from other planets to our planet, or endogenous synthesis, means formation here on Earth itself. Okay, so the exogenous delivery is actually the theory of panspermia, that maybe some life material has been means delivered to here, like Zomato or Swiggy. Some may have delivered here on Earth. Okay, and then based on the other theories like the Oparin-Haldane theory, that is like it said that the Earth in the past was like a soup, where it was it was steaming with heat, and like also there was too much of heat and also volcanic activities, and also too much of you can say chemical substances, like in a soup, dense soup kind of thing, and their reactions took place and eventually life emerged. Okay, and then there is the RNA world hypothesis that says, means the chicken and the egg thing, like which came first, like that RNA came first or DNA came first. Okay, both are equally plausible, but we don't know. And that's important to know whether life means which one came first, because like in the time scale of how life evolved, maybe RNA got a different role and DNA got a different role, but initially RNA or DNA were similar in the beginning. Okay, but then there are other theories like the Urey-Miller hypothesis that says that maybe the chemical substances like in the atmosphere under the influence of thunder, means generally life requires three things: energy, water or any liquid substance, and the chemical materials, okay, or organic molecules. So the substances here under the influence of thunder, that's giving the energy, the electrical energy, may have produced biomolecules. And this experiment was simulated in the last century, at the end of the last century. So Miller and Urey, the two scientists, and what happened that they found in that simulated experiment that amino acids and other biomolecules were formed. Okay, and apart from that, there is hydrothermal vents. That is again like kind of formation of life in the presence of heat from the magma or lava, means in the ocean floors, and obviously in the ocean floor you will get water, and under the ocean floor there are small volcanic type features, okay, that are called hydrothermal vents. Okay, and they consist of minerals, and also the reaction is taking place in the presence of energy and the water out there. So they are kind of a source, a potential source for life to have originated in such a place, and not only under this ocean. And we know like life came from the ocean or from the waters as per the evolutionary time scale, as we have seen. And also it can be also on the surface, means like Surface in the sense like as you move up towards a volcano is that are inactive, you will find many kind of ponds or lakes that are very heated, very much heated by the magma that's beneath the lake or that particular water body. So energy is there, water is there, and the reactions takes place on the surface of the river bodies or the lakes. And in that way also you can consider the hydrothermal vent theory comes up. So there are many theories, but remember, they are not like you may be thinking that only one of these theories can be right. It can be, and it is that each of these theories complement each other. Okay, and life may be a product of or a combination of all of these processes taking place together. We never know. Okay, but now there are more theories and more things coming up, but hopefully that is a more advanced stage of understanding. Okay, and our Earth in this cosmic time scale of 13.7 billion years was formed around 4.5 billion years ago from today. And in this time scale, earlier it was thought that Earth was heated by was a kind of magmatic hell where volcanic activity was taking place every day. But then again, in the year 1999 or like 2000, I don't remember exactly, but there was a study of zircon ancient minerals in Australia, and it was found that there was water around 4.4 billion years from today. But then again, where did the organic molecules come from? Energy we can understand maybe from the sun or like that time volcanic activities, or each of the hypotheses have their own regions where energy is supplied, be it in the hydrothermal vents or be it in the atmosphere or other. But remember that study of the organic molecules essential for life is very different. There are two approaches. One is top-down approach, like moving backwards from today, like through study of fossils, study of the the tree of life. But then again, as you know, on Earth there are tectonic activities and a lot of volcanic magma like form layers and all. So during the formation and as Earth and like life interacted with Earth, the evidences got washed out. So today we have lesser and lesser evidence of the fossils. But then again, there is also a bottom-up approach where we study from the atomic level and molecular level and formation in space to Earth. And these are the two approaches that are being considered. And finally, coming to the last part of the concepts on astrobiology, then I'll move on to the opportunities. I know it's a bit boring, but still, I think so. The excitement should come from inside that we are knowing about ourselves. How did we come about, right? But about exoplanets, hopefully many of you know already, but still, like from the very discovery of the first exoplanet and many debate on that and getting a Nobel Prize in 2019 or 2020, I don't exactly remember. But then today we have so many discoveries of 5,000 exoplanets, right? And that are kind of confirmed. And in our own galaxy alone, that's the most fascinating thing. Like once somebody has or some group has to kickstart the thing, and it goes on like wildfire. And then there are possible, you can say, habitable worlds in our own solar system. That is kind of, as you can see here. Can you all guess the names of at least a few of these? Like
yes, I think the red one is Mars,
right,
and the yellow one is Venus.
So can I try?
Right. Yes, Keshav.
So the blue one will be Titan, a moon of Saturn.
You mean the green one, right?
Yes.
Right. Rajiv, you have something to add? The other two, the white ones, the brown one. Yeah. Riddhi, you mean Europa means which one?
Yeah, one more is Pluto. Red one is Pluto.
No. There is no Pluto here. You mean this one is Europa, right?
Yeah.
Okay. Right. And this one? Excuse me. Anyone? Okay.
I think this big size orange ball is a Jupiter. Red is Mars.
No, 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 no. The Jupiter is
It's
not.
Venus. It's Venus.
Right. So this one and this one are our very dear neighbors. One is quite mysterious enough, that's the Venus, and one is quite explored enough, that's the Mars. This one is Titan, the moon of Saturn. This one is Europa, and this one is Enceladus. Enceladus of Saturn, the moon of Saturn, and Europa of Jupiter. So these are one of the few of the most potentially habitable worlds that NASA is looking forward to in form of future missions, and hopefully few more public agencies will look forward to further exploration of these. And finally, coming to the three main aspects, what we are looking for. We are looking for molecules. Okay, we are looking for life. There is simpler form of life, that is biosignatures. And last but not the least, the green guy out here, our dear alien. Yes, we
Yeah.
are also looking for the technosignatures. Through technosignatures, looking for intelligent life. Okay, so all these three aspects form what astrobiology is. And that's what the beauty of astrobiology is. Life to moon, Mars, Venus, and beyond. And do not forget life on Earth as well. And that's what astrobiology in general stands. I've tried my best to explain the brief about astrobiology. Without further ado, I will go on to the opportunities and the bonuses I have for you all today. Kind of World Space Week bonus. So, how to become an astrobiology professional? A journey from astrobiology enthusiast to being an astrobiologist. And remember, I am an entrepreneur, and I will not only talk about being a researcher, but also a communicator and entrepreneur and other fields as well in the field of astrobiology. So, I'll share another tab for a moment. Just a second. Yes, one can visit our website www.life2andbeyond.org, and you can go to the repository section on our website, and you will find this particular infographic that we have made. It is inspired by NASA's infographic on how to be an astrobiologist, but the NASA's astrobiology graphic is more related to the American education system only. We have tried to be more inclusive and considered, you can say, opportunities and events from across the globe, and made this infographic a few months before. So I'm sharing that infographic for you all. I'll share the link as well for download on the WhatsApp or also on the chat later on at the end. So you can find that the 5 steps to become an astrobiologist. This is just a, you can say, you can consider this. There's no straight path to astrobiology. First thing is you have to nurture your interest in the field. From getting interested to learning to even connecting with people of similar mindset, of similar interest. You're interested, that's not enough. You have to sustain your interest. You have to protect your interest, because it's highly difficult in today's date to sustain your interest among so many interesting things and finally impact that particular field. So we have a lot of hyperlinked resources out here, peer-reviewed courses or newsletter, or even like different kinds of things. Like, for example, I'll just take one of the best resources you can consider if you want to study astrobiology is the Astrobiology Primer. It's a free resource. PDF can be downloaded. You can even print it. Okay. It's written by more than 50 professionals in the field of astrobiology in the most simplest manner possible. Okay. It's 98-page kind of document. The Astrobiology Primer, or you can say initial resource 2.0, version 2.0. You can always download it. And coming back, like for example, okay, wait. You can, after clicking on that particular link, you will get this one. So similarly, going back to the infographic, you'll find many more things here, resources. Now, the second step is getting a degree in your field of interest. It's highly important, and not only like sciences, it can be any field. You can consider all of these fields listed down here. And remember, try to learn about different fields, not just be focused on your field. Okay, try to appreciate the inter, and multi, and transdisciplinarity of astrobiology and even space as a whole. Space is for all. Okay. And finally, use your knowledge base that you learned through your degree or like through your external knowledge and all to solve a problem in astrobiology. like solving a question by being a researcher in astrobiology, or communicating or educating people by communicating them about the recent developments and engaging people through events like these. Okay, be a space communicator, be a science communicator, educator. You can even manage your initiative of your own, like I and Arjit and our teams do, by creating opportunities for future astrobiology professionals as an entrepreneur or even space professionals and many more. Okay, then find your tribe. As I mentioned, it's highly difficult to maintain your interest. So find your tribe. Means find people who are as interested as you are, so that every time you get opportunity, know about opportunities from them, and even share about opportunities that you come across. Okay, come across a community. And finally, you can see here the Life to Beyond community, as well as the Blue Marble Space Institute of Science, Sagan, Net, Ulan, and all, Origin of Life Network, Early Career Network, and all, hyperlinked out here. And also keep upskilling and keep networking, because these are at the very base of what you can say astrobiology or any other field requires. There's persistent efforts towards one's goal, love and passion for one's work, and flexibility to face and resolve unforeseen situations will eventually bring success in any career path, be it in astrobiology or any other. Find your way beyond, my dear friends. Okay, if you wish to join astrobiology, you can consider following these steps and these resources and all, or even in other fields of space or even other fields of human endeavor. Okay, you can also check out this one, 5 steps to get started with space life sciences and all, but that's another talk. There's another discussion for this. So coming back to my slide, back again. I'll share the link of this infographic with you all so that you can get access to it. It's free and open for all. Coming to, as I can consider that most of our dear audience is from India, the following set of slides is dedicated to people who think that astrobiology is a new field in India and perhaps work isn't done or happening in India. So behold, my dear friends, what astrobiology work is happening in India. In terms of academia, there are these many institutions in India. It is continuously updated from Life to and Beyond every day, every moment. And I'll take some names from here. Obviously, I'm not affiliated or like allowed to officially represent them, but as an open resource, I can always share it with people and about different initiatives. Okay, because we are trying to contribute to an ecosystem. We are not in a competition. Remember that. Okay. Like, for example, if I talk about one of the finest centers in India is the Center for Excellence in Astrobiology, the Amity Center for Excellence in Astrobiology in Amity, Mumbai. Then the COOL Lab, or the Chemical Origin of Life Lab, working on prebiotic chemistry and origin of life, Dr. Sudha Rajamani in IISER, Pune. Then you can also check out tardigrade research in IISC, done by Dr. Eswarappa's lab in IISc Bangalore. You can also look for astrochemistry work done at NISER Bhubaneswar in the Earth and Planetary Sciences Department. Unfortunately, I don't remember the PI's name. And then you can also look for some work at PRL. Obviously, they are also working on astrochemistry and planetary science works, and some work on extremophiles done similarly here in Dharwad. One of the persons who has been affiliated with NASA as a postdoctoral fellow and is working now on extremophiles and has come back to an agricultural institute. Okay, I'll share the name of the agricultural institute. Unfortunately, I'm not remembering the name as of now. And there are many more. If you wish to know more as per your regions, I can share it in the Q&A. Coming to analog sites. Can you all share what analog sites are? What is an analog site?
Actually, I've never heard of it.
Others?
Places where large telescopes are placed so that we can collect large amounts of radiation data, something like that.
They are telescope centers for sure, but not analog sites. Yes, one of the analog sites does have a telescope for sure, I'll share. but I'm talking about it with regard to this map. There are thousands. There are like many, more than 50 analog sites across the globe. Yes, Keshav.
So I think where you get all the data collection and that stuff, like
What
the
data collection?
place where you do, like all the where you where like these are the centers where you work on the uh, like astrobiology data samples. So you get these data samples from these areas.
What do you think can be those astrobiological data samples? What kind of data?
Like it can be like example JWST
No, no,
checking
no,
for
no.
habitable homes and that.
Right, habitability can be one of them. Right. Yes, Aditya, you want to add something?
So like I'm not sure about that, but like according to the
Aditya, could you be a bit loud? I think some network issues. In the meantime, we can ask Preet to share.
Yes, sir. So I think so that analog site means those are the sites from where samples of the samples are collected of different the house conditions and different things where
Right.
we can think of growth of life where it started from and such there.
Right. That is a very good answer here. Yes, Aditya.
so now you can hear me.
Okay, miss. Despite me insisting many a times, not calling me sir, still you continue to do so.
Sorry,
Okay.
sorry. Can you hear me?
Yes, yes. Perfect.
I had some internet issue earlier, so
Yes, yes. Same.
like according to me, if we say locations of these all analog sites, they are all in areas which are very harsh, like Ladakh, Kutch. Kutch is like a desert like, and Lona crater and Lashman Hills, which is in Antarctica. So, like the environment out there and the climatic conditions out there,
Mm-hmm.
from that, then we can see like it. They can get the you can see the factors which can allow life and the important factors which are needed for life to means take place or yeah take place.
Right. They are kind of sites or places which can be analogous or similar to other planets where life may be possible. Like, for example, Mars or Moon, or like even some craters on other planets. Even Venus has analogs on Earth. Okay, so the thing that means everything we try to means find a kind of simulated environment. No, that is only analog site. It's an analog of Mars. It's an analog of Venus. It's an analog of like Enceladus. It's an analog of maybe Moon and all. So here you can find some it. This is Ladakh. That is Mars, the Mars Analog Research Station by Amity Mumbai only. That's near the Hanle region. There is also the telescope out there that I was mentioning, and the Dark Sky Reserve exists there. So that's an analog site actually. Okay, some regions out there is the dry, cold desert like Mars. Okay, and also the Kutch region is a good like analog site for the moon as well as the Mars because of its that soil out there. Okay, and also the white desert kind of as it is called. And PRL is doing some research. Akash Space Studio, some of our friends are doing some research out there. Then Lunar Crater, as you may many of you may have known, a meteor many years ago kind of created that feature out there. It's a very big now this lake is also there. So it's considered an analog for the Jezero crater on Mars. And many extremophiles study many kind of mineral and geological study. Like I think so, there is a speaker on geology in some days in this particular series. So you can ask him about this particular thing about lunar crater and many more. He will be better be able to explain it to you. And then there is also Larsemann Hills in Antarctica in collaboration with some Indian research Antarctic stations. Hopefully, in future we'll have that. And there are many more within India and across the globe. Okay, given many audience are here from India, I'm sharing about India in general. So these analog sites, occasional visits are okay, but also full-fledged research stations need to be set up there. Hopefully, someday it will be. And already there is in the Kutch by Akash Space Studio. So private endeavors are coming up soon. And on that note, I will move on to the astronaut training. As you all know, the Gaganyaan mission is coming up. Though it is not much astrobiologically relevant, more towards space biology or space medicine. But obviously, in terms of astronaut training, it's important to note that our India also will be setting up a fully sophisticated astronaut training center in the near future, in the next few years. And also, as of now, there is a temporary facility at the Institute of Aerospace Medicine that is helping out in in the training of Gaganauts after their training from the Yuri Gagarin astronaut training center in Russia. And last but not the least, coming up to initiatives or private entrepreneurial initiatives, obviously our friend from Bareilly, Resolute Lab, are doing a great work. It's certainly humbling to see initiatives working on space biology and such initiatives on biopayloads and all. There are other initiatives as well, one in Hyderabad and Coimbatore as well, trying to come up with such ideas and such products as well. Then in Pune and in Calcutta, also we have two of our friends, Astro Capsule and also Extra Universe, who happens to be a collaborator of this event. So they are also doing great work in terms of spreading space education. And obviously, there is one more non-profit, IASES, working in Calcutta with regard to astrochemistry. But then obviously Life 2 and Beyond comes into play, working in space social sciences, space life sciences, as well as astrobiology in general. So you can always look forward to and also encourage such kind of initiatives that are trying to do something different from the conventional things that is done across the Indian subcontinent or even across the globe. Okay. And that's the map of what astrobiology work is done. And that is Life 2 and Beyond, as you can see in its animated version. Its logo, we envision to empower the unsensitized communities, not just the developing or underdeveloped nations, but also the unsensitized communities in astrobiology, space studies, and applications. We are on a mission to foster ethical research and development, education, and outreach with an entrepreneurial spirit to venture beyond as well as to save our pale blue dot. It's an initiative of the young, for the young, and by the young, and expert mentored as well. And together we contribute to a diverse and inclusive space ecosystem together. And we are humbled to play our part in this growing space ecosystem. And these are the intersection where we work in astrobiology, space studies, and application, also in general space and science, technology, engineering, arts, and mathematics. And this logo is particularly important, as I mentioned, that you need to remember only that particular quote. We are made up of star stuff. The cosmos is within us. We are made up of star stuff. We are a way for the cosmos to know itself. Our logo is inspired by that very thought of Carl Sagan as well. The cosmos is within us. We are made up of star stuff, the star trail attached with this DNA strand as a DNA strand, and we are a way for the cosmos to know itself. This particular part, half, represents our globe, and the many unknown worlds is represented by this concentric circles out here. And that is what Life 2 and Beyond means. Initially, we started with the name of Life to the Blue Oasis and Beyond, means life. To the Blue Oasis means the fertile land of Earth. Okay, and beyond, like the journey of humans from stars to Earth and beyond. Okay, back to the stars. That is what the essence of Life 2 and Beyond logo and its name is. And then it was very long enough, so we shortened it to Life 2 and Beyond. So the 2 is also important out here, and the and is also important out here, and the beyond is also important apart from the life part. So many call us by Life and Beyond, Life 2 Beyond, many things, but actually it's Life 2 and Beyond, inspired by Carl Sagan and his thoughts, continuing to inform and involve and inspire people in the domain of astrobiology, space, and its applications. Moving on to the next slide. Yeah, we work on research and development, science communication and outreach, community building, and sharing information about resources, events, and opportunities. And these are our fields of work for this term, as you can see here. And apart from this, there's a bonus, as you mentioned, as I mentioned at the very beginning, about sharing about opportunities with you all. As a part of Space Crew, it's a kind of a working group of Innova Space company of registered in UK, and also its global presence there. And I've been recently the coordinator of this particular working group. So young people are always welcome. Obviously, means all applications do not get considered, but only some based on their interest. We not only try to help people contribute to the group as well, but also the group contributing to their own career. Okay, a group of space enthusiasts from across the globe, from Africa to South America to North America to Europe to Asia and even Australia. Okay, it's a truly global working group. You can always join us. You can write to me. I can share with you the relevant details. And then is the Young Scientist Program. You can always check it out at the beginning of like February, March. The applications are out. The Young Scientist Program stands out to be one of its own kind program by Blue Marble Space Institute of Science, providing internship in an online as well as offline mode in some cases. But the best part is the online mode work that you get to do. Like I have been a part of this particular program very recently as an undergraduate. Okay, I'm in my second year of undergraduate studying chemistry, and also as a part of this Young Scientist Program, recently I have finished it this term, and I have been promoted to the Visiting Scholar Program, where I am associate. My work essentially during the Young Scientist Program was related to Enceladus, Venus, and phosphine and phosphates, generally phosphorus as a biosignature. Like generally, there are many research coordination networks of NASA. So one of them is the NASA's um, network for light detection, N-fold as they call it in short. So one of the initiatives is the LDKB, a database of potential biosignatures. Why? What is it? It's a kind of online, you can say, community-based and open source database of all kinds of biosignatures known to date, and anybody can share that, but also supported by evidence. It has three parts: a background section for general overview for newcomers. Then there is a, you can say, arguments, like what argument do you give for a particular thing to be a biosignature? And then there is supporting evidence by scholarly peer-reviewed literature. Okay, so in that way, it's a great database, and future missions of NASA and other initiatives as well are going to be supported by the studies uploaded on that particular database. Okay, so now I'm working on that particular database, and in future would also like to get to work on some literature, work on some technologies related to NASA missions as a visiting scholar. You all also can try to be a part of this particular program next year when the applications are out. I will share more details in the WhatsApp group, the link as well, or in the chat during the Q&A session. And finally, coming to one more opportunity that is going on alongside this particular event is the Spacepreneurs Program, outreach as a part of the Outreach Sarabhai initiative of Life 2 and Beyond. The best part being that the topics that we are trying to cover as a part of the Spacepreneurs Program through fireside chats and also the special sessions as well as the panel discussion of young spacepreneurs. We are going to host this 10th of October. You can always register for this event, and I think it's the best thing is that the timing of both these events of our friends at Resolute Lab as well as Life 2 and Beyond doesn't coincide. Like you can attend our event from 5 p.m. whenever you can, and also join Resolute Lab's talks, and it's a full day of celebration of space, entrepreneurship, and different topics related to space. And one more bonus here is being a part of the Spacepreneurs Program, attending at least 2 sessions out of the 12 or 13 sessions that we are hosting. It's already 2 days. Now there are many more sessions left. It's a truly global initiative hosting people from all across the globe, experts, spacepreneurs, astronauts, and as well as like young spacepreneurs, high school students having their space initiatives. Think of that, right? And we are thinking we are doing great things. So it's an inspiration from their end. So as one of our partners, as a giveaway, people who attend at least 2 sessions and also share their feedback about the event as well, honest feedback. Okay, you do not need to say good things about our program, but you also get a chance to send your name and photo to the moon, etched in quartz technology in a time capsule by LifeShip US, and that will be sent on a lunar lander by Firefly US on board Falcon 9 rocket of SpaceX. So we are giving it as a free gift to all our participants. So feel free to join us and also join Resolute Lab in its celebration of more 4 days. So happy World Space to you all, and thanks to Resolute Lab on doing such a great initiative in this sense. And finally, coming to the entrepreneurship or the leadership part. Can you all say these two mad people, kind of people used to consider them? So on the backdrop of my slide, who are they?
So one is Vikram Sarabhai and another is Homi J. Bhava.
Right. What did they do?
They launched the first rocket from India and
Uh-huh.
also set up the Indian space program under the atomic energy. They were the two pioneers of the Indian space program.
Right. Means it's a bit different here. Like Homi Baba obviously complemented the space program, but he was not directly involved there in the sense. But then he was directly involved with the nuclear program as we had from India. So there were two visionaries, and this particular photo continues to inspire me, as if like Homi Bhabha showing the future to his mentee as well as like colleague and friend, Vikram Sarabhai. Okay, so like they not only thought out of the box, but also led the path out of it. And today we know what their initiatives have, like kind of what the fruits of their initiatives are being beared, and like we are having the fruits of their initiatives or their starts, right? So remember, my dear friends, that have your own vision. Okay, is whatever you do, you start a startup or like a non-profit or whatever you do, or even like do a job or anything, have a vision, like what you are contributing to the society. Okay, then have the courage to get on the path of your vision. Okay, because that's the most important, because half of us not even think, and those who think, they do not have the courage to get onto the path. Okay, and then be persistent enough to follow your vision. It's not that today I start, tomorrow I fail. Okay, as Jack Ma says, today is difficult, tomorrow is more difficult, day after tomorrow's morning is also difficult, and day after tomorrow's evening is success, or is a good day, or a good evening, right? And most people fail the day after tomorrow. So the thing is that we have to be persistent enough. Success will come. Okay, and then be ethical and work for the greater good, not just for profit, but also impacting the society at the greater level. That is what I personally feel I have learned from the stories of these two pioneers and many more people who continues to inspire me, and I know that it will continue to inspire you as well. And on that note, this is just a signing off from of a Beyonder, as we call in Life to and Beyond. All its members are called Beyonders, thinking beyond, but also our foot on the ground here on Earth. And this is a snap of the poster. Would like to add a snap of this particular session in this collage in future sessions, contributing and obviously justifying the particular topic that we discussed today. That is astrobiology, making space education more accessible to all. Generally, in India, we consider physics and engineering to be the standard paths of what people should, that people from all fields can join space. Each one has their own role to play, and there's no bias, and there's not just one path. There's multiple paths to the same thing, that's space. Okay, and that's how astrobiology as a subject, connecting so many things, so many people, so many initiatives together, is making space more accessible to all on a global scale. Because it's about us, it's about our story. Okay, and on that note, I thank you all again, and wish and also thank Resolute Lab for this invitation. And we'll continue to do our part from here, life to and beyond. And wish you all a very happy World Space Week. Keep celebrating space, keep celebrating entrepreneurship, and happy World Space Week again. Thank you very much, everyone, for your time. I'm open to any questions or even positive criticism, if any, and discussions.
Sir, I want to ask a question.
Sure.
As per my knowledge, the fundamental key element of life is motion. If a particle or anything organ which have motion or speed, what you can say, so it's mean it is alive. So on that theory, if we can see the atomic structure, neutron and the proton, electron, they have motion and the speed. And in a depth scenario, can we take it as a signal of life in atomic structure?
I didn't understand actually. Like means you're first like on one part you're connecting motion. I understand like there are atomic level motions as well, but like you are connecting on one side atoms and also on the other side movement of life, because it's remember what Carl Sagan said. He said it's not the atoms that's the beauty of life. It's how those atoms are arranged. Basically, the molecular structure. Okay, life is almost like food, making a food, like making a bread or a roti. Means you just need not just mix the elements or like the components for making that roti or the chapati, whatever you make it. Okay, you have to maintain the order, the temperature, the pressure, and many more things needs to be considered. As for the motion, as you said, yes, motion is one of the key features of life, but there are many life forms that stay in one place, idealized. What will you think about, what are you going to say about them? They are also life, right?
Yes, correct.
So that's why it's very difficult actually to
This
define.
was a theory that I heard somewhere in social media, that even you can imagine life in atomic structure.
Okay, in atomic structure, it is quite is
I
fascinating
have
enough.
I have a question.
Why? Just a second. Like in the sense that atomic struct atoms make life. Life doesn't make atoms. Okay, if you think that in that way, means theory is not like just random perspectives. You have to back it by something. Okay. Yes, Himang, means Ghosh, you can go ahead.
Yeah. So as we know that the life is made up of atoms and molecules and biomolecules, but if we go at the very fundamental level of atoms, we can see that atoms are not living,
Hmm.
but they make a system which is living and self-sustaining. So
Right.
how is that possible?
That is the very beauty of life. Okay. Like for example, see, I told about the very definition of life by NASA. Like for example, Ghosh, I think so. You are very well aware of, hopefully, means about the basic chemistry, right? In your from your school level,
Yeah, yeah, sure. Sure,
let us
sure.
take hydrogen and oxygen. They both are gases and they both have distinct characteristics. But them adding them means under proper conditions, they make water that's a liquid in general room temperature, and it has different features. Compared, it's completely
Exactly.
different from what hydrogen and oxygen is, and that's what
Mm.
means the components that make life may have different properties or may not be lively, but the product that is made by them is completely different. And remember that life is a set of chemical reactions. It's not just one chemical reaction. Okay, you think of your own body as a combination of so many things, not just as a single entity. Okay, and all those structures, like it is a complete machine that's working like at a very fundamental level. like at the DNA means encoding the information generation after generation, or like transcription and translation processes, then like building, like multiplying of cells, and like shedding off of dead cells, and then using up of energy, then what is it called, transfer of oxygen through different body parts. It's a complete machinery process, right? So in that way I'm trying to explain that you cannot like think when simple chemistry equation and compare it to life. Life is a different level of set of chemical reaction that can self sustain itself. That's the best part, it doesn't require anyone's help. Okay,
Yeah, yeah, exactly.
I think so there are some questions in the chat as well. Just a second. Does it mean life as we know it or form of life? Yeah, life in the universe, it can also be like any form of life, not just carbon based life. Even many sci-fi professionals and all have also considered saying about silicon based life, given the properties it comes in the same group out here. So the thing here that silicon and its bond with hydrogen and other means like oxygen and others is not that strong enough. And the most important thing of carbon is that it's very strong enough to sustain high condition, means high temperature, as well as like maintain that thing to kind of replicate, or like even the reactions to keep going. But in case of silicon, it isn't. Okay, but yes, in future research, we may get to know more about different forms of life. Let's see. Then I feel each object in space has a basis of life, but evolves only when the suitable conditions develop. Yes, absolutely. There's no doubt in that. Then, yeah, dark matter and dark energy. This two things, though I'm not much of a person of astrophysics or so, but still what I know I will share. But even the astrophysics people have much difficulty defining it. Dark matter is something that is not something that doesn't much interact with the conventional matter as we know it, and it's in many cases they say that it is very much responsible for the extra mass of different galaxies in our universe. Then in case of dark energy, it's something that is also sped up means speeded up the very expansion of our universe as we know it. Means initially, means logically speaking, if I just go back to the slide here, just a second, the story of our universe, that particular slide. Um, oh, it's, I think I missed it. Yes. Generally, like it was hot and like condensed into a small mass, and eventually it was not an explosion. It was a kind of expansion of time and space. Okay, and excuse me. So eventually, what happened that it became cooler and cooler, but at a point, suddenly technically speaking, when it becomes cool, the expansion should slow down, right? But now we are seeing that the expansion has exceeded, means kind of again started, means begun to happen actively, and the universe is expanding. So it is said that the dark energy is mainly responsible, but how and why I'm not sure about that, and even people are looking forward to it. And when they know it, perhaps they'll get the next Nobel Prize in physics for sure. I can say maybe you can do it, some of you. I'm sure about that. And then we have, I think so. Sham says that through spores, yes. In the hydrothermal vents, maybe there are spores as well. They also contribute for sure. JWST is a telescope. It has nothing to do with planets. And then Keshav says places on Earth with assumed past or present geological, environmental, or biological conditions of a celestial body. Yeah, perfect definition. And what is the fate of ISS? Okay. See, the international means any kind of space activity is driven by geopolitical activity here on Earth as well. As you all may know very well, as per the recent Russian and Ukrainian war, mainly Russia and its module will back off in some years, but it is kind of considered by 2030. It will be kind of um, means the working will stop and it will kind of come down as a space debris in the, I think so, in the Pacific Ocean, hopefully. Uh, and now the data that NASA and other space agencies, JAXA, Roscosmos, and others have collected through their experiments in the ISS, it will further help them in lunar exploration and beyond. So, like NASA, in as per the Artemis Accords, in collaboration with like ESA, hopefully as of now, in future maybe some other space agencies will join them. They will try to make a lunar space station as well, as they call it, the Gateway, as a part of its Artemis program. And as, because China and Russia aren't a part of the Artemis Accords as of now, um, they will try to work on a separate lunar station to work on their own part. So this, I think so, is the future, and also India also plans to make its own space station in the near future. Roscosmos as well uh, tries to have its own individual, and even some private endeavors are looking forward to space hotels and all. They are also space stations for sure that they are considering. So this the whole overview of space stations that I have, at least in my limited knowledge. Is NASA uh, planning to replace it with another high-tech space station? I don't know as of now. What's below Earth? Okay. You mean under the crust of Earth, or like, if you could just briefly mention, or like specifically mention, it will be helpful. Okay, Shah asks, a news heard about plant growth in ISS. Okay, not just a plant growth, it has been practiced for a long time now. They try to plant in the space environment as well. Different kinds of plants, because see, in terms of sustainable space exploration, we cannot take everything from Earth. We have to develop something. Excuse me, please. We have to develop something in space as well, or even on other planets, to kind of sustainably maintain the survival of humans in space and also continue our journey beyond. Here, in this context, I would like to share one small story. That's the story of our humans in the past. We started our journey from Africa, and as per like one of the articles I was reading from Nat Geo, um, uh, so it said that the humans took around 50,000 years for traveling through different subcontinents to Australia. So that time they didn't think about much of the casualties they faced, or in the oceans, in their like what about like journeys across the oceans, and also like through different kinds of environments through land bodies. I think so. It's something that's in our spirit of humans to continue exploring. Okay, that time we were just just in one continent, and today we are multi-continental. And today we are in a similar situation where instead of the oceans or the perils that we faced at that point in time, the space radiation, the microgravity conditions, the psychological issues that we face while going to space is the barrier that is kind of barring us from becoming multiplanetary. Okay, so I think so. This story shall continue to inspire us, and in that endeavor, we have to be sustainable enough, and like growing plants or like food material, or like even having sustainable fuel systems, having sustainable water supply by recycling our water, be it from the waste or like other activities, even like having cool design, like compared to the ISS, the Chinese space station is actually far cooler. Obviously, the technology is pretty recent, so we have to consider many things in terms of space exploration. It is going to be hard, but not, you can say um, it's impossible. So I would like to share one last quote from one of our previous speakers as a part of our previous World Space Week celebrations at Life to and Beyond. He was a space architect. He said that there are three quotes by three distinct people, but it goes in line. It says, "The future belongs to those who dream. Second, the future belongs to who believe in the beauty of their dreams. And third, but not the last, the future belongs to those who work for their dream from today." Okay, I believe that Resolute Labs and many more initiatives like us at Life to and Beyond and many more people here are working towards our dreams. And I wish you all the best for your dreams. And on that note, I will end today's session. Thank you again, Resolute Lab. The floor is yours.
Yeah, thanks, Palit. Thanks a lot. And you totally explain what is life in astrobiology field and what is life in real. Okay, so you explain both the perspective. Okay, as per the astrobiology as well as the entrepreneur's perspective. Okay, so yeah, it
Thank
was
you.
really a great session, and I hope the audience enjoyed it. Okay, it's looking by their reactions. Okay, so yeah, at last, I just want you guys to turn on your camera so that we can have a snapshot with our keynote speaker. Okay, just everyone, just yeah. Aditya, Rajiv, Keshav, Hari. I guess Keshav is also going to have a session. He's a young entrepreneur. Okay, so I forgot his company name, but yeah, he's one of the young entrepreneur. Okay, so yeah,
Great. Great to know about your work. Would love to know more about your initiative and your works and vision and mission for sure.
yeah, sure. I guess cameras are open. I think my internet is not working. That's why I can't see the cameras, the faces of you guys. Palit, it's fine from your side, so you can take the snapshot.
Oh, yes, yes, for sure. Just give me a second.
Mm.
Just a second, please. Let me first stop sharing and
Mm.
change the.
Yeah, yeah, now I can see everyone. Yeah, great.
So, will you be taking it?
Yeah, I will be taking. Okay. Yeah. So just smile and happy World Space Week, guys. Okay. So yeah, thanks guys. Thanks for joining today's session. Okay, I can see one of
Thank
your
you,
team
sir.
member, Palit, Darshan. I guess, he's
Right,
from
right.
yeah,
Finance officer.
yeah.
I'd like to. Thank you, Darshan, for joining, and thank you, everyone, and happy World Space Week.